Hi, 7th grade. Welcome to your video for Thursday, April 16th. Yesterday, you were introduced to the immune system when I had you watch the video by the Bob Jones University Press teacher, and she walked you through section 20D of chapter 20 and gave you just sort of an introduction to how our body fights off disease. You may remember that we have non-specific defenses like our skin and inflammation, our mucous membranes, fever. Those are all defenses that can work against any type of pathogen, any type of foreign invader. They're not specific towards any particular kind of invader. And then we have our specific defenses, which is really what would technically be called our immune system, where the cells in our body, particularly our white blood cells, work together to try to recognize and to eliminate threats that can come from all kinds of different pathogens. So today I want to talk to you a little bit more about that specific immunity and how our white cells, some of our white cells work to accomplish that. Immunology is one of my favorite subjects because it just highlights the genius of God and his incredible graciousness in providing us with such a good system for fighting off threats to our health and well-being. Because of the fall, sin and the effects of sin, disease and sickness entered our world, but God didn't leave us defenseless, which was very gracious of him. And he put into place a multi-layered, very complex system to allow us to recognize and fight off things that can harm us. And immunologists are those scientists who study the immune system, and lots of them are hard at work right now in the CDC, the Center for Disease Control, to try to understand the effect that coronavirus is having on our bodies and how we can help our immune systems fight the coronavirus, like through the development of vaccines or particular medicines, or through implementing social measures like distancing to give our immune system time to work and give scientists time to develop vaccines to protect people. They're just personal heroes of mine. So I didn't want to leave this subject without talking to you a little bit more specifically about how our blood cells can work to protect us. Now, this is a big, complex system, and I really don't even have the ability, like I'm not skilled enough in this area to teach you about all the different ways that our blood cells work together. It was the hardest subject that I took in graduate school, the hardest subject, honestly, that I've ever studied, but very fascinating. And there's just a lot to it that I don't fully understand. So I couldn't teach you it all if I wanted to, but if I did want to, it would probably take like I could have a whole year-long course on it. That's how complex it is. So I'm just going to show you one little part that I hope will help you appreciate the way that God's designed you, and some things that are happening inside our bodies all the time to help protect us. Okay, so I have to show you a number of different pictures, like to do this, and it would be easier for me to do it in my classroom rather than sitting at my desk in my bedroom. But I'm gonna try my best, so please be patient with me as I sort through that. Okay, so first thing I want to show you is that when we talk about the immune system, we're talking about a system that's really complex with lots of different types of cells that are all working together. And what makes it complicated is that, let's just take this cell, for example. This is called the helper T cell. The helper T cell can have an effect on this type of T cell called a suppressor T cell, which in turn can then turn right back around and have an effect on this one. The helper T cell also affects this cell, this cell and this cell. And when this cell is affected, it can affect this one and these. But, you know, there's just all these interrelated complex interactions between the different types of cells, which makes it hard to figure out. I am going to talk about some killer T cells today. I'm going to talk about some B cells, and I'm going to talk about some plasma cells and antibodies and kind of try to help you see how those guys work together. So I'm going to be kind of talking about this section right here, but there's a lot more to it. Okay, so one thing I want to remind you before we get started is that these are cells we're talking about. So the cells, they float around in our bloodstream, if you want to say. So this is a blood vessel. And remember, you learned last week that blood is made largely of the fluid portion, which is plasma, but you also have these different types of cells that float around in it, lots and lots of red blood cells that carry oxygen and carbon dioxide, but also lots of white cells. And these white cells, which are called leukocytes, they work together to help our bodies fight off disease and sickness. Now these leukocytes, these are really good drawings, but they actually look more like this. So they have a different, they don't have really any one definite shape. They're kind of more blobby, whereas red blood cells are sort of always this raft shape. And they come in lots of different varieties. When you look at them all together, like, so this would be a microscopic image of some blood where you have the red blood cells here, you have some white blood cells here, which have been dyed orange, and then you have some platelets here, which are green. So these types of cells are floating through our blood all the time, and they can also leave our bloodstream. The white blood cells they can leave our bloodstream and enter what's called our lymph or lymphatic system, which is another fluid that doesn't have red blood cells. It's not blood, but it's another fluid that circulates around our body and helps us fight disease. So we're going to talk particularly about the white blood cells, a couple of types of the white blood cells, and what they do when they encounter a foreign antigen, a foreign invader in the body. So to do that, I'm going to actually have you look at a drawing that I made a few years back to help my 7th graders understand this idea. And I'm going to start here in the drawing with this type of, this is supposed to be a white blood cell, and I've tried to kind of give my cells some personality so that you could understand their different roles. This is a helper T cell, and it's important for him that he sees very clearly. He's always on the lookout, which is why I gave him glasses. I did not, however, really intentionally try to make him look like this character, Arthur the Aardvark, which was a show that my kids loved a long time ago, but oh, sorry, I don't think you're seeing Arthur right now. Let me show you Arthur. So here's Arthur, right? So you notice that Arthur's head kind of looks like my helper T cell. That was just by accident because I'm not a great drawer, but get the idea. Okay, so helper T cell. Here we are. Let me try to fit this to the page. Here we go. Okay, so here's our helper T cell. He's on the lookout. He's circulating around the bloodstream with the red blood cells, the platelets, the other types of white blood cells, always patrolling to see, always looking to see if he can spot an invader. Now, the way that he knows if he spotted an invader is if the invader has something on the some molecules on the outside of the invader's body that he doesn't recognize as being something that his body normally has on the outside of his cells. So that's one reason I made these little sort of rounded humps on the outside of the helper T cell that I drew, because let's say that's the protein that he's used to seeing. That's the kind of molecule that a lot of the cells in the body have on the outside of them. Well, when he sees that these invading bacteria don't have those circular shaped proteins, and instead they have like a spiky molecule on the outside, he realizes like, okay, they don't belong here, and they need to be dealt with. And those little molecules on the outside of the cell are called antigens. Okay, so he sees these antigens, he knows they're not native to his body, and so he knows there's a threat. This is really oversimplified, but it's sort of the best example I can think of. Like, let's say that this guy had a uniform, and let's say his uniform, he was a Boston Red Sox player, okay? So he wore a Boston Red Sox cap, okay? And let's say that the evil invader happened to have a Yankees cap on, okay? So when this Boston Red Sox helper T cell sees somebody come into the bloodstream that doesn't have a Boston hat, instead they have like a Yankees cap on, he immediately knows, oh, you're not part of our team, you don't belong here, so we need to take you out. Okay, so that's what he does. So once he realizes it's a threat, then he, I like to tease Ben Baldridge about being a Yankees fan. So there you go, Ben. Once he realizes that these guys don't belong because of their different molecules on the outside, their different antigens, he does two things. The first thing he does is, well, I don't know if it's the first thing, they might be done at the same time. One thing he does is notify B cells, another type of white blood cell floating in the bloodstream, that there's a problem. And the B cell is going to carry out its job and react like it's supposed to. And I'm going to get back to that in just a minute. But the other thing that the helper T cell does once he realizes there's a foreign invader in view is he activates what are called killer T cells. So these killer T cells are like killing machines. Their whole job is to bind, like to seek and to destroy the invader. But they're not always active. They can be inactive. And an inactive killer T cell would be like a soldier taking a nap on their bunk or whatever. Okay, they're not actively seeking out an enemy, they're just resting. But when they get the signal from the helper T cell that there's a threat, they become activated, and this is, I make it where their fangs come out, they're ready to kill. So now they're on high alert, and they're going to be, as they're floating through the bloodstream, they're going to be ready to take out the enemy. Okay, so they're ready. Now let's go back over to the B cell. The B cell, who's been notified that by the helper that there's a problem, makes what are called plasma cells. And I made it so that these plasma cells have little chef's hat because their job is to make a very specific thing. And the thing that they make is called an antibody. So these B cells, they say, okay, hey, plasma cells, we need you to do something for us, make some antibodies. Well, the cool thing about these antibodies is they're molecules, but they're designed specifically to attach to that particular antigen. So the B cell tells it, hey, we need antibodies toward that antigen. We need something that's going to bind to that antigen, that's going to stick to these invaders, that make it like hyper obvious or super obvious that these are the bad guys. Okay, so the plasma cells, okay, no problem. They make a bunch of these antibodies. These antibodies are designed to specifically bind to this particular antigen, and they release them into the bloodstream. So as these guys are floating along in the bloodstream trying to cause trouble, these antibodies will just, when they come into contact them, will bind to them. And now these bacteria will have these little antibodies stuck to their surface that basically have marked them. And once they're marked like that, then the activated killer T cells know, okay, that's my mark, that's my enemy, I've got to take them out. And so every cell that has those antibodies stuck to it, the killer T cells will literally eat, like engulf. And they're just one cell big, so they don't like have a mouth that eats it. They wrap around the invader, bring it into their bodies, and have it join with a lysosome. Remember, the lysosomes are the organelle inside the cell that can break stuff down, and it'll break down the invader. So we have our helper T cells working together with our killer T cells and our B cells to respond to a threat and to make it possible for antibodies to be produced that will bind to the bad guys and allow the killer T cells to recognize those guys very quickly, so that they can be destroyed. Now, what a vaccine does is a vaccine allows us to, we get like a little shot, and what that shot is a lot of times will be just the antigens. So when you go and get your flu shot, what you're getting are little pieces from the outside of the flu virus, and they get put into your bloodstream. Your helper T cells see those little pieces and are like, whoa, I don't know what those are. I don't recognize those proteins. Hey, B cells, help me out. The B cells will make a bunch of antibodies against them. And then they will bind to the antigens and be destroyed, but that doesn't really matter because those antigens alone wouldn't have made us sick anyways. But what's important is that what's not shown on this page is we also have memory cells, and the memory B cells, what they do is they can remember that they've made those kinds of antibodies before, that they've seen that antigen before, so that if the actual pathogen comes in that has that antigen, so like say the flu virus comes in your body that has that antigen on it, your B cells know already like, oh yeah, hey, we've seen that before. So we'll get right on pouring out antibodies into the bloodstream. And so it can do this step much, much faster. So before this guy has a chance to get very far at all in the body, these antibodies have been made, have attached to the pathogen, and the killer T cells have taken it out before it even has a chance to have a threat. That's why scientists are working so hard right now to develop a vaccine for the coronavirus, because we want to have something in place where our body already knows, yep, I'm familiar with what the coronavirus has on the outside of it, so I'm just going to go ahead and make all those antibodies. Those antibodies are going to attach to the coronavirus. My killer T cells are going to take them out, and I'm going to be fine. It won't even have a chance to make me sick. So I did want to show you a picture under the microscope of a killer T cell. I don't actually know if this is a killer T cell because there are other types of white blood cells that do this too, but this is a white blood cell wrapping itself, it's purple, and it's wrapping itself around this green, the structure that's been dyed green, which is the bacterium. It's the anthrax bacterium. It's going to wrap all around that, bring that bacterium into its body, and then break it down. So that's what I mean when I say that it's going to, the killer T cell is going to, eat it. I mean, it's going to take it in like that. Okay, so I think that's all for today. I know that's a long video, but I just wanted to be able to share that with you because I think it's such a beautiful picture, like I said, of God's creativity and genius, and just, again, like I said, and it's just a small part of all that's there. Okay, y'all have a good day, and I will talk to you soon. Bye-bye.